Hi, I'm Dr. Christopher Sutton, and welcome back to my Introduction to GIS video series. In this video, we will explore how GIS helps us uncover hidden relationships and trends in geographic data. Whether you are analyzing urban growth, mapping wildlife areas, or planning transportation networks, understanding spatial relationships and patterns is key to making informed decisions. Spatial relationships and patterns focus on how geographic features are arranged and interact in space. Specifically, spatial relationships describe how features relate to one another in space, and spatial patterns reveal the organization, distribution, and regularity of phenomena across geographic areas. Spatial relationships can be classified into several fundamental types, including proximity, connectivity, containment, adjacency, overlap, directionality, density, and accessibility. Let's look at these one by one. We'll begin with proximity. Proximity is the nearness or distance between two or more features. For example, the distance between schools and residential neighborhoods, or the proximity of hospitals to population centers. Central to understanding proximity is distance, which is the amount of separation between locations. We measure distance in two primary ways, using linear units of measurement, feet, miles, kilometers, and so on, and using time measurement, days, hours, weeks, years, and so on. Let's look at an example of linear and temporal distances by examining this map, which shows west central Illinois. In the northwest corner of the map is the city of Macomb, Illinois, and in the southeast corner is the city of Springfield, Illinois. Linear distance in this example can be measured as the straight line distance between Macomb and Springfield. People tend not to travel in a straight line between Macomb and Springfield, so linear distance might be measured as the route between the two cities. We also can measure this in terms of time. The shortest drive time between Macomb, Illinois and Springfield is 1 hour and 44 minutes, and we use both linear distance and temporal distance frequently in our day-to-day lives. The strength of a spatial relationship between two objects or locations often is affected by distance. Geographer Waldo Tobler famously coined what is known as his first law of geography, stating that everything is related to everything else, but near things are more related than distant things. Connectivity is the degree to which different locations or features are linked by networks or relationships, such as transportation routes, communication systems, ecological corridors, or social networks. Containment is the spatial relationship where one feature is entirely within another. For example, counties within a state, a park within a city, or a habitat area within a protected region. Adjacency is when two features are next to each other or share a common boundary. For example, properties sharing a common boundary, or countries that are adjacent on a continent. Overlap refers to the spatial intersection or common area shared between two or more geographical features. This concept is critical in understanding relationships between different spatial phenomena. For example, roads intersecting rivers. Overlap can occur when comparing wildlife habitats with urban development zones to identify conflict areas. Directionality refers to the orientation or movement of objects or phenomena in a specific direction, such as traffic flow, migration patterns, or water currents. Density measures the concentration of a specific attribute, like population or vegetation, within a given area. It provides insights into the spatial distribution and intensity of phenomena. For example, population density in urban areas versus rural areas. Accessibility refers to the ease with which people can reach specific locations or services, such as healthcare facilities, schools, or markets. We might use GIS to analyze the accessibility of hospitals in rural regions. Spatial patterns describe the arrangement of phenomena across geographic space and can reveal important insights about underlying processes. Patterns are often categorized as follows: clustered patterns, dispersed patterns, random patterns, linear patterns, and radial patterns. Let's look at these individually. Clustered distributions, or more simply clustering, refers to the process of grouping objects based on their spatial proximity or similarity. This technique helps in identifying areas where features, such as points, lines, or polygons, are concentrated. Clustering is used for pattern recognition, data analysis, and the visualization of complex spatial data, making it easier to identify trends, anomalies, or significant groupings within the data. On this map of Waffle House restaurants, we can see locations where clustering occurs. Dispersed distributions occur when features are spread out or scattered in geographic space. GIS can be used to analyze the dispersion of a species in an ecosystem, showing how certain animals are distributed across a landscape. Linear patterns involve spatial arrangements that follow a line, often reflecting movement, flow, or alignment along a pathway. Examples of linear patterns in GIS analysis include analyzing the spatial distributions of accidents along a highway, mapping stream networks to identify hydrological connectivity, analyzing urban sprawl patterns along major highways, or tracking seasonal wildlife migrations along predictable linear paths. Radial patterns involve features arranged around a central point, extending outward in all directions. Examples of radial patterns in GIS analysis include mapping bus or train routes radiating outward from a central hub, analyzing urban expansion in concentric zones from a central business district, mapping areas covered by a cell tower signal strength, or modeling lava flows from a volcanic eruption. By understanding spatial relationships and spatial patterns, we can use GIS to solve real-world challenges. Join me in the next video where I will cover the geographical concept of movement.